General rule of thumb is never put a CB radio on the weekend.
Thank God for that. Yeah, I'm out here in these old piney woods. I like it. Peace and quiet.
A station in Poland, all I can copy is 77 something. I do hear you in there. You're pretty weak. 766 Pennsylvania waving.
Oh, I don't hear that guy in Poland, but I hear my friend 766 out there. You know who it is in a diesel wagon, 73.
Hey, 73's Troy. Thanks for dropping in, man. Yeah, that guy over there in Poland, I'm sorry. I did hear you come back to me there, sir. We're just going to wave at you there, Poland. Thank you very much for coming back to me. You have a wonderful day, sir. Yeah, sorry, I think you said 775, I'm not sure. Yeah, I was just looking for somebody to put on my YouTube video here.
How you doing, Mike, in Pennsylvania?
Bye-bye, Poland. Hey, man, how's everything going up there in Canada?
It's going. Howdy, howdy, Mike.
Yeah, I appreciate you giving me a shout there, 128. I can still hear that guy over in Poland. But I was just looking for somebody, you know, one or two people to put in the beginning of my video. So I'll stick that 9250 diesel wagon in there for sure, and that guy in Poland.
It's always a pleasure to hear you on here, Mike. It's always a pleasure to watch your videos, too.
766, needlebender 948 waving.
Needlebender 948, I got you in there, weak copy, but we got you. How you doing today?
Hey, 766. Tell that mud duck out there in San Diego that needlebender 9250 said to bump it up.
I know, Troy. He was a needlebender that called me out there, wasn't he? Yeah, I had a hard time hearing him, but I definitely hear that diesel wagon.
Yeah, I got no copy on Donnie right now, but I got a great copy on you, brother. Sounding grand on the band. 73s.
Hey, 73s, man. Thanks for making it into my YouTube video.
Thanks for putting me in it.
Okay, YouTube. Hello. Thank you for watching. I got a voltage reference here today to put into this board here for this clarifier. Before I do that, I just want to say that there's a big, huge problem here. And the problem is this. You see what that is there? That's an empty box. So there's a million things I want to say about this, but I ain't going to say anything at all. So with that out of the way, let's see if we can get this voltage reference in here. This is an LM4051. It's a precision micropower shunt. So it's a shunt voltage reference. It really acts the same as a adjustable Zener diode. Also, you can adjust the voltage on this one here really by the same means as you can any 3-terminal regulator, just by providing feedback resistors. So this is adjustable from 1.24 to 10 volts. It has a temperature stability of 50 parts per million and an accuracy of 6 millivolts. Initial accuracy is 0.2%. You can get these adjustable or you can get these fixed. They may only be 5. I'm going to see if we can get this in today. I think the best position for this is going to be... Going to have to dig out a slightly better pair of glasses for this, because these things are very, very small. Yep, there it went. There it went. Alright, where'd it go? This is just the way things work. Well, it didn't fall through the radio. That never ever happens. I'll tell you what my absolute best guess is. You can call me an optimist. I bet it's laying down underneath here where I can't get to it. As I was saying, this, my friends, is exactly what it's like to work on a radio. I don't sugarcoat anything. So, this little reference diode is kind of like so. You have an anode, a cathode, and then you have the adjust tab on it, which is pin 3 over here. So it's basically just a Zener diode, but it's an adjustable Zener diode. So this little thing has got to set in there, and that's looking at the top view. So let's get it to the board. Try to get it flipped so the top is up. So the pin to the right, as I hold it right now, is the anode. That's got to go down towards this right here. Now I don't think I'm going to be able to do this with a camera in front of me because I can't, I just can't do this. So there's two in. That one's soldered, that one's soldered. This bottom one, I've got too much space there. And I can't bridge that one in. Take a piece of 30 gauge wire wrap to make up the distance in the span there. I absolutely can't see a thing. Absolutely can't see a thing. Got this under the best magnifying glass I got, and you can't see nothing. Well, there it is. It's in there. But you know, if you can't see it, that's alright, because actually I can't see it either. That's about all my camera will magnify there. Let's put 13.6 volts into that thing. When I did that, I heard this relay click down here, which is a good sign, because I don't know if you can hear that, but when the mode switch goes into AM, it takes the 5 volts from the clarifier circuit, puts it over here onto this relay, and pulls in this relay to change the Roger beep settings, so you can control the Roger beep independently on AM and upper and lower sideband. So when this mode switch is in SSB, this relay down here is off. And like I said, that all keys off of this 5 volts. If you lose clarifier voltage, you'll lose your Roger beep. We should have something extremely close to 5 volts here. And we do. Now, I don't have the right diddle stick here. These kind of trimmer pots are a real pain in the ass. If you don't have the right diddle stick for them, you're going to lose your mind to try to adjust them. So we want to spin that. Till that reaches 5 volts. Like so. Now that's a 5 volts. It's never going to change. It's always going to be 5 volts. Probably within less than 6 millivolts. And that is the 5 volts to the clarifier on the DDS-BFO that we don't have in the box. Should have about 8 volts here. We got 7.96. So this 8 volt regulator here provides the current and the voltage for that 5 volt reference diode. And then this 360 ohm here sets the current down through that reference diode. That reference diode will only handle up to 10 milliamps. So basically what you got is 8 volts through a 360 ohm resistor to keep it pretty happy. That'll keep it happy about 8 or 9 milliamps of shunt current through it. There's a divider network here, which is a precision 7.5K through this Bourne's 250 ohm 10 turn, and then there's a another precision metal film here, which is a 2.4K. That sets up the divider to feed the adjust pin to adjust that regulator, because that regulator, like I said, will go anywhere between, and technically it's not really a regulator, but it works similar to one. It will go anywhere from 1.24 to 10 volts. The internal value of its reference, you could kind of look at it as being 1.224 volts. So that's all good. Now, another thing too I did is I replaced these foil pieces in here. They were aluminum foil that slides over the edge of the plastic here. They go down and they brush against the chassis, and then when you put the cover on, they connect everything together. So the cover is bonded to the chassis, basically. It's just what these pieces do. I use copper because that's what I had, but the factory had aluminum ones in there and they were all tore up. And as I said, this is a Roger beep board to be able to independently control the beep volume for AM and upper and lower sideband. AM was on the top here and SSB's here on the bottom. So when we flip the mode switch into AM, it pulls a signal relay on. It just brings these pots and these resistors down here in and out of circuit. If you want to stress yourself out, right there's the way to do it. Another thing too here, the nice thing about this Madison as compared to the 142 GTL was this board here was a lot friendlier, even though getting the display into it was a lot harder to get the OLED display in. But the board has lots of pads up and down along the side here that you can use for connecting the cables into it. That way it's a strengthening point. That way you don't have to try to connect wires directly to the OLED pins up here where stuff can break off. So everything just gets tied through those cables to these pretty beefy pads over here. So that worked out pretty well. There's a 330 mic cap set in here. There's an RC, this resistor, and that cap. So the 5 volts comes through that 47 ohm, hits that cap, and then comes up here and goes into the power pin on the OLED. And there's a chip cap soldered across up here between VCC and ground. So you can see all the connections I made down onto the board off of these pins here directly. I just used wire wrap wire because, I mean, wire wrap wire, in my opinion, is the greatest thing in the world. Also, one other thing I'd like to point out is just something I do, is I take the load off the power switches on these things, the on-off switch on the front. I take the load off of it to save on the switch itself. So I put relays into these so that when we turn the power switch on, the power is actually being switched through the relay. This is a triple pole here. Just ended up, this is what I had, and these are cheap relays. They're an Omron relay. These relays will also fit into like the TRC 457, 458 and stuff like that, but they're probably one of the worst. Well, I don't know if I want to say worst, but I think they're just kind of a case of a Omron relay that's not very good. Let's just put it that way. I have nothing against Omron, but these relays here, they suck, and anybody that's had a TRC 457 or 458 can probably vouch for that these relays are nothing but problems. So that's why I used this one, not because it's nothing but problems, but because I had hundreds of these things. So when we turn the power switch on, all the power current is actually being switched through this relay. And that kind of pertains to my next project here, which is going to be to put a new on-off switch and volume control into my 142 GTL. I haven't looked up the specs on these switches yet, the two back contacts for the switch here, but my guess is these things aren't rated to carry 2 or 3 amps of current. Just something I do on all my radios, and it's probably a good thing to do that too, because finding the original on-off switches, I don't know if a person could ever do that. These are pretty good ones here, but it's just they're not made to switch that kind of current. So putting the relay in there definitely fixes the problem and takes a lot of stress and strain off of stuff. Also too, I guess I should mention the spectrum analyzer amplifier board is done. It's a duplicate of what I did in the 142 GTL. There's a -5 volt adjust pod here. There's an offset null here to zero the output down to 0. And then there's a gain pot right here. So the signal comes off the detector diode from the receiver from the S meter, comes over and goes into this amplifier board, comes out on this solid gray wire here, and goes into the empty DDS VFO box. 13.8 comes over on this red wire, which all comes down onto this terminal block right here, because like I said, all power is switched through the radio by this relay, so the main power connections are over here on this block. That's pretty much about it. So anyway, hey, thanks for watching my video. You take care and have a great day.